Myself, Supriyanand, Assistant Professor, Department of Electronics and Communication Engineering, RIT. We shall see the experiments on Analog and Digital System Design Laboratory BECL305. In this video, we shall verify and design the crystal oscillator. Usually, crystal oscillators are used in order to get the stable sinusoidal signals. So, despite of number of variations due to the temperature, humidity, and some other circuit parameters. Then, what do you mean by these crystal or the crystal quartz? A piezoelectric crystal is used in the oscillator as a resonant tank circuit. In this particular circuit, we are not going to make use of any input. Instead of the input, we design the tank circuit which will act as a feedback. So this feedback will produce some oscillators or oscillations which we are going to calculate for the frequency. When an AC signal applied across the crystal, it vibrates at the frequency of the applied voltage. Conversely, if the crystal is forced to vibrate, it will generate a AC signal. So the commonly used crystals are quartz, Rothschild, etc. So in our design, we are going to make use of quartz crystal, which is of 2 megahertz. We shall see the circuit diagram. Here you can observe. Here we have made use of a BJT, which is SL100. So from the base, we are going to connect the two resistors, that is R1 and R2 of 3.3 kilo ohm and 8.2 kilo ohm. And across the collector, we are going to connect across the output. So for the output, we need to connect the capacitor of 0.1 microfarad. So here we are going to provide the VCC of 10 volts and the across the, that is the collector resistance as 1 kilo ohm. And you can observe we have made use of the emitter. Across the emitter, we have taken the variable pot, that is variable resistance of 1 kilo, and the emitter resistance as 470 ohms. We are having a feedback, that is across the emitter feedback as CE, that is of 100 microfarad. What you can observe is the crystal across the output. The crystal is connected. This will be the quartz crystal, which is of 2 megahertz theoretically. We know in order to calculate the practical values, you need to calculate the theoretical values first, and whatever the practical observation will be there, that has to be verified with the nearby value across this theoretical value. We have taken the crystal across the output, and from the output you can from the CRO you can connect it for the collector and check the voltage what we are getting. So the procedure is to switch on the power supply and check the DC connections at the first, check the sinusoidal waveform at the output, that is across the collector. And if the input is distorted, then we need to adjust the 1 kilo potentiometer, what I said it as the variable resistance across the emitter to get the perfect sine wave. So then we need to measure the time period across the oscillation and calculate the frequency accordingly. We need to measure and compare the theoretical as well as the practical value. We'll see the circuit connection as well as the output waveform.
The circuit connection for the crystal oscillator is shown here. This is the quartz crystal of 2 megahertz. We have taken the circuit with the 10 volt VCC, that is power supply. Theoretically, the crystal value will be of 2 megahertz. We need to calculate the same and verify along with the practical connection. Once the connection is done, here we have taken the pot of 1K, which is a variable pot. Vary the pot along with this and verify the circuit. Here you can observe the frequency. This is nearby shown frequency. This is of 1.2 division. So if this is 1.2 division, the time division what we have set here is 0.5. In order to calculate the frequency, we need to verify the same, that is from the oscilloscope we have got 1.2 into the time division is 0.5 into 10 power minus 6. This is in microseconds. We have got the value. The formula is to calculate the frequency is 1 divided by T. I am going to substitute the same answer. Here you can observe the value what we are getting is 1.6 megahertz into 10 power 6 megahertz. The theoretical value for the crystal is 2 megahertz. We have got practically 1.6 megahertz due to some power fluctuation variation. You need to verify it along with the theoretical and practical value. So this is the circuit for the crystal oscillator.